Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. In this video, we're working on solving systems, but we're going to be working with some substitution. So all that's meaning is this: we're going to take one of these equations and replace it into the other equations, solve for one of the variables, and then place it back into the original equation. And you'll see what I'm talking about in just a second. So for number one, it has y equals 6x minus 11, and then it has the second equation as 2x plus 3y equals 7. So since it has already one equation set up where it has one variable on one side and all the other terms on the other, I'm going to substitute that in. So I'm going to say, instead of y in this second equation, I'm going to have 6x minus 11. So I rewrite that equation. Make sure you use parentheses, to show multiplication. So I'm going to say, instead of y, I have 6x minus 11. So the whole equation is now in terms of x. So I have 2x plus 3 times the quantity 6x minus 11 equals 7. Make sure you're using that distributive property. So if you need to draw that little box for yourself, all I'm going to be doing is I'm going to be multiplying 3 times each of the terms inside of those parentheses. So I'm going to say, all right, I have 3 times 6 and I have 3 times a negative 11. So I write the products inside. So I'm going to say 3 times 6x is 18x. And then I say 3 times negative 11 is negative 33. And so now I can write that underneath of the purple part in green. So now my equation is 2x plus 18x minus 33 equals 7. Make sure you can combine like terms. Work on one side of the equation first. So I notice, hey, I have a 2x and an 18x. They both share the same variable to the same power, so I can combine those together. Again, make sure you're just adding those or combining those coefficients. So I'm going to have 20x, and then I have minus 33 equals 7. Now we're trying to get that variable by itself, so I'm going to make sure I use my inverse operations in red. And so I'm going to kind of draw my railroad tracks if we need to, but I'm going to add 33 to both sides. Whatever I do to one side, I have to do to the other. Again, otherwise your equation becomes unbalanced. So now I have on my left side 33's cancel out, and the 20x comes down, so I have 20x equals 7 plus 33, which is 40. Last step, always divide by that coefficient. So I'm going to divide both sides by 20, and so I have x equals 2. So now all I have to do, I have half my problem done, because I know that it has to be an ordered pair. So I'm going to take that value and substitute it back in for y. Or excuse me, I'm going to substitute that back in, and I'm going to solve for y. There we go. So instead of x, I now have 2. So I rewrite that first equation. I'm going to say y equals 6 times 2 minus 11. And then I can just simplify and get a singular value for y. Again, make sure you're using those parentheses to show multiplication. So I have 6 times 2 is 12, and then everything else stays the same. So then I do 12 minus 11, which is 1. So that means my y value is going to be 1. So now that I have an x value and a y value, I can write my solution as an ordered pair. So that has to be an x value and a y value in parentheses like this. So again, make sure all your answers are going to be like this. So again, it's kind of like a first name and a last name. It's kind of like a street name and a house number to get to a location. And so now we're going to say that solution for these two equations, meaning the solution for the system, is going to be the point 2, 1. So again, make sure you can pause, rewind, replay anything you need. Make sure it asks questions as they come up. So what I'm going to do for this video, I'm going to go through the odd problems, and that way you can solve the even problems on your own. For number 3, the system is y equals negative 3x plus 5. And then the other equation is 5x minus 4y equals negative 3. So I'm going to take this expression, negative 3x plus 5, I'm going to plug it in for, let's say, actually I may back that up. I should be plugging it in, yep, for y. Because I'm saying that instead of y, I now have my equation in terms of x. So now I can rewrite it. I have 5x minus 4 times the quantity of negative 3x plus 5 equals negative 3. Again, you use that distributive property to get comfortable with it. If you need to go back and rewatch videos that we had from solving equations, working with a distributive property, make sure you do. So all I'm going to do is I'm going to multiply that negative 4 times the negative 3x and the negative 4 times the positive 5. So again, make sure you're taking one term at a time. That way you can make sure you're multiplying carefully. So same sign positive, so I have positive 12x, and then I have negative 20 for my other product. And so now I can say underneath of that I have my equation 5x plus 12x minus 20 is going to be negative 3. So now again, combine like terms, I can say I have 5x and 12x. That becomes 17x because they're both positive integers. And so I have 17x minus 20 is going to be negative 3. And so now I can isolate that variable, two-step equation, get all the constant terms on the other side. So I need to add 20 to both sides. And so now I'm going to say on the left side I have 17x equals 17. Real simple, divide by that coefficient always. So again, real simple, it always tells you exactly what to do. And so now I'm going to say my value of x is going to be 1. So now I can take that value, plug it back into my original equation. And so now I can rewrite it like this. I'm going to say y equals negative 3 times 1 plus 5. Then I can say, all right, use those simplification skills. Negative 3 times 1, negative 3, and then plus 5. That's just going to be a positive 2. So now I have my y value. Make sure you write it as an ordered pair. And so I'm going to say my solution is going to be at the point of 1, 2. So again, x value, then your y value, write it as an ordered pair. So the solution to this system is going to be the point 1, 2. Moving on to number 5, just doing these odd problems first, and I'll let you do those even problems on your own. So it has x equals 8 minus 2y, and I'm going to plug that into my other equation, x plus 3y equals 12. And if you notice, hey, all I have to do is real simple, just kind of slide it over because I'm going to have the second equation all in terms of y. So I'm going to rewrite it. I have 8 minus 2y plus 3y equals 12. Make sure you can combine those like terms. So I have negative 2y and a positive 3y. What's left over? Just 1y. Get the y value by itself. So I'd subtract both sides by 8, and so I'm going to say y equals 4. Take that value, plug it back into my equation. So I'm actually going to let me slide that just a little bit in. I'm going to say, hey, it's just going to replace that y value. Everything else stays the same. So I have my equation x equals 8 minus 2 times 4. So then I'm going to say, all right, make sure you follow order operations. Multiplication first, so I do negative 2 times 4 is negative 8. And so I do 8 minus 8 is 0. So now that I have my x value, I have my y value, write the ordered pair, which is the solution to this system. So I have the solution point for the system of equations is going to be at the point 0, 4. Moving on for my number 7, or for the system, I have x equals negative 2y minus 1. I'm going to plug that into my second equation in for x. So now I'm going to rewrite it like this. I'm going to say 4 times negative 2y minus 1. And then I have everything else stay the same, so I have minus 4y equals 20. So make sure you're very careful when you're kind of switching these equations. When you rewrite it or substitute it in, it should always be in the same variable. So I should always have an equation in terms of one variable. Use that distributive property, so I'm going to multiply each of the terms inside of the parentheses by 4. So I'm going to do positive 4 times a negative 2, different signs negative, so I have negative 8y, and then I have a negative 4. So I'm going to say negative 8y minus 4 minus 4y equals 20. Combine those like terms, common variable, make sure you are adding carefully. So again, negative 8 degrees gets colder by 4, so I'm going to say it's going to be negative 12. Again, use that Desmos calculator, double check if you need to. Two-step equation, get the variable by itself, so I add 4 to both sides, and now my equation is negative 12y equals 24. Divide both sides by that coefficient of negative 12, and so now I have y equals negative 2. As soon as you get that value, plug it back into your equation that you didn't use, and so I'm going to say, hey, instead of y, now I have a negative 2. So I rewrite this first equation in terms of x, so that means I shouldn't have any other variable besides x. So I should have this, I should have x equals negative 2 times negative 2 minus 1. Make sure you multiply carefully, same sign positive, so I have positive 4 minus 1 equals x, which is just going to be 3. Again, make sure you can write your solution as an ordered pair, so I'm going to say my solution for this system of equations is going to be 3, negative 2. Moving on to number 9, one more after this and I'll be done. I have 3x minus 11 equals y, so I'm going to take that expression and plug it in for y into my second equation. So I'm going to have 5 times the quantity 3x minus 11 minus 7x is equal to 1. So it should always be in terms of one variable after I substitute it in. Make sure you use that distributive property, multiply carefully. So I have positive 5 times 3x is going to be 15x, and then I have positive 5 times a negative 11 is going to be a negative 55. Write it underneath, so I have 15x minus 55 minus 7x equals 1. Make sure you combine like terms, 15x and negative 7x. I'm going to have 8x left over, and so I have 8x minus 55 equals 1. Add 55 to both sides, trying to get that variable by itself, and so I have 8x equals 56. Make sure you divide by the coefficient, so I divide both sides by 8, and I end up with x equals 7. So take that x value, plug it back into the other equation, and so now I'll be able to get my value for y. So I rewrite this equation like this. I'm going to say 3 times 7 minus 11 equals y. So when you rewrite it, I shouldn't have an x anywhere because I replaced it with a 7. Multiply carefully, so I do 3 times 7 is 21, minus 11 is going to be y. So I'm going to say y equals 10, which is going to be my value for y. Make sure you write it as an ordered pair, so I say my solution for the system is going to be the point 7, 10. So again, always in the form x, comma, y in parentheses. And last problem in this video, I'm going to say y equals 6 plus 4x. Substitute that in for y. Be very careful on this one. Make sure you're seeing, okay, how many y's are in that second equation? I only see 1, but it's going to be a negative 1. So make sure you're saying I multiply negative 1 times each of the terms inside the parentheses. So notice how I multiplied the negative 1 times 6 to get negative 6, and I multiplied the negative 1 times the 4x to get negative 4x. So if you need to draw the box for yourself and do the distributive property, make sure you can. So now my equation is negative 5x minus 6 minus 4x equals 21. Combine those two like terms. So I have 9x minus 6 equals 21. Two-step equation, get the variable by itself, so I add 6 to both sides using those inverse operations. So now I have negative 9x equals 27. Divide both sides by the coefficient, so always make sure, some people are going to just divide by 9, make sure you have to divide by negative 9 because I'm just trying to get x equals a value. So I'm going to say x equals negative 3, take that value, plug it back into the first equation. Again, it should be kind of root 2 by now. Make sure you can say, okay, I have the equation y equals 6 plus 4 times a negative 3. Make sure you simplify carefully, so I'm going to say 4 times negative 3 is going to be a negative 12, so I have y equals 6 minus 12, which is going to be a negative 6. So I have my x value, I have my y value. write the ordered pair. So I'm going to say the solution to this system of equations is going to be -3, -6. Again, be very careful. I feel like a lot of people are going to kind of flip these back and forth. Always in this form, you know, x first, then y. Again, make sure you can ask questions. Be sure to pause, rewind, try out the even problems on your own. Use these examples that I just did, and as always, super slam that subscribe button.